Welcome to your PN5 note guide. This is the title is Solving Equations and Complex Numbers. These are prerequisites that as you come into pre-calculus you should have. So as we're doing the note guide today, really you could do most of it yourself, but then use me as your check to see if you're doing it correctly or not. So you can actually do it two ways. You can just listen to me and work with me, or you can try it on your own and check to make sure you're doing it correctly. So nothing here is anything that you've never seen before. This is all very, very much a review before we get into Unit 2. So the first thing is solving equations, quadratics in particular. In this case, we're solving this quadratic equation right here, x squared minus 7x minus 18 equals 0. We've already done this as a review at the beginning of the year, but you know, though, that we have a trinomial. This is how I do it. Of course, you might have a different method, but I know we have an x here and an x here. I know we have alternate signs because the only way to get a negative 18 right there is by multiplying a positive and a negative number. That's how I think about it. 18 itself, I can go 1 times 18 to get 18, 2 times 9, 3 times 6. And I'm really looking at what is going to end up subtracting to 7, or in this case, negative 7. So I can see that my 9 is going to go here and my 2 is going here. So this is the factor pair that I'm going to be using. So this is me solving by factoring in the sense that I have it factored. Now I actually have to solve it. I can set this factor, linear factor equal to 0, this one over here equal to 0, and then solve each one. So I have x equals 9, or x is going to be negative 2. Okay, so that again is just a very quick talk about factoring trinomials. This one down here you can definitely do on your own. Notice it's a little bit more complicated just because you have a factor besides 1 in front of the x squared, and again you have to make sure you set it equal to 0. So I am going to factor here. I actually, just for the sake of saying it, I actually am looking to see if I can actually divide out anything in all terms. So like I saw the 2 and I saw the 6, I needed to see if I could also divide the 11 by 2, which it isn't possible, because that is definitely, pulling out a GCF is a great way to reduce your factors to make it a little bit more factorable. Anyway, I know this is going to be 2x here, this is x here. I have one positive, one negative sign, and I really don't know what it's going to be. I'm just going to put alternate signs. I might end up having to change that. I would definitely use a eraser or pencil if you're anything like me. I know I have factor pairs of 1 times 6, 2 times 3. So I know I'm either going to put 1 and 6 in or 2 and 3 in. And really, you know, if I want to, I can start with 2 and 3. I check my inners really quick, which is negative 2x. My outers really quick, which is 6x. And that gives me 4x. That does not give me the 11x that I want. So that is not going to be what I want to do there. So I'm going to come all the way back down to this right here. So 2 and 3 does not work. Of course, I should be able to flip it, see if that works. But I'm going to try this 1 and 6. The thing is, I already see the answer. And again, there's no problem just trial and erroring it in there. But just check your inners and your outers. So my ins right now is going to give me negative 1x. My outers right here is going to give me 12x, and that's going to give me 11x. Now if I ended up with negative 11x, I wouldn't move any of my factors. I would just change my sign here, minus 1 to plus 1, and this plus 6 to minus 6. But again, it's not necessary because I have exactly what I need. So again, trial and erroring it, you know, really factoring, you start picking up patterns, but really ultimately just be aware that it is making sure you check those factors to see if you're getting what you need to. Okay, so I'm setting each one equal to 0. I end up with x equals 1/2 here, or x equals negative 6 here. So again, I know I'm kind of going through this very quickly. This is a rehash of really starting from Algebra 1, but it's not bad to look at. Solving using square root method. So just to kind of keep in mind, we solved quadratics by 1, factoring, 2, by this thing called the square root method. And really it has to be in vertex form. So unlike factoring, which tends to be in standard form, now that we're in vertex form, this is the method to solve by, which is square rooting both sides of the equation, but only after you isolate. So make sure you remember to isolate your square. So that's one thing you need to know or remember. So I'm going to add 7 to both sides. So I have 3x minus 2 quantity squared equals, what do we have there, 16. And then that's when I can take the square root of both sides of the equation. Now the other thing to remember, there's really only two things. One is completely isolate your square. It's kind of like isolating your square root. It's the same idea because it's the same type of idea. And then don't forget, when you square root both sides of an equation, don't forget, oh my gosh, your plus or minus. So you have two solutions there. So let me bring this over here. So I'm square rooting both sides, so I end up with 3x minus 2 equals plus or minus 4. Once you have that, this is what I tend to do. I add in front of the parenthesis, or you can even set up two equations if you want. But I'm just going to add right in front of my plus or minus, and then I'm going to divide out by 3 here. So now I'm for sure going to separate because I have two solutions here. So I have 2 plus 4 divided by 3, and I have 2 minus 4 divided by 3. That's minus. So what do I end up with here? I end up with 2, or the other solution is negative 2/3. Ironically, if you did expand this out right here by multiplying it out and then getting it in standard form and factoring it, you'd get the same solution, but it also would take you about 10 minutes longer. Well, maybe not 10 minutes, but it takes longer. So the square root method is the ideal method to use when it is in vertex form. Your quadratic is in vertex form. If it's in standard form, that's when we use factoring. And if it's not factorable, then we use what's called the quadratic formula. So again, notice that this is standard form right here. And again, with a quadratic, if you think about it, you're talking about solutions where they hit the x-axis, because that's, of course, graphically where solutions are. If you think about parabolas in general, there's usually two solutions. The only time there is one solution is if it's bouncing on the x-axis, or no solution is if it's shifted up like this here, and we'll talk about that in just a minute. So typically, a quadratic has two solutions. And now we are going to talk, I'm not going to do that. We're going to talk about the quadratic formula. And this is something that is memorized at this point in the game. Before you get to pre-calc, you should definitely have this memorized. But it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And that gives you your solutions when it's not factorable. Now, really, a test for the quadratic formula is this, to see if it's factorable. And we talked about this at the beginning of the year. B squared minus 4ac, that is the discriminant, and if that is a perfect squared, then you should be factoring it. Otherwise, if it's not, then you have to do what I'm doing right now. So again, we need to get this in standard form, so that's 2x squared minus 5x minus 4 equals 0. And if it helps, put your a value off to the side, b value off to the side, and c value off to the side. Now in pre-calc we keep things in exact form, but we also need to know how to approximate them as well. See, we need to do everything. So let's throw this into the quadratic formula. X equals negative 5 plus or minus the square root. I'll write it all out this time. Usually I do some work right away. Negative 5 squared. And I'm using a stylus that, because of how hot it is in my room, is starting to get weird. All over 2a, 2 times 2. So this is where you're going to simplify it. And just be careful when you're simplifying it to not lose negatives and to make sure you're following your proper order of operations. So this is 5 plus or minus. Of course, negative 5 quantity squared is a positive 25. So don't just use your calculators, make sure you're using them right. -4 times 2 times -4 is going to be a positive, what is that, 32 all over 4. And I write very, very large. I get larger and larger as I write. So I end up down here, x equals 5 plus or minus the square root of 57 all over 4. And really, you can leave it like that, but I'm just letting you know that typically, at least in our pre-calc textbook, they tend to express the answers like this right here. Either one at this stage is fine because there's nothing more to simplify, but if you could simplify, let's say, the 5/4, then you would have to break it up like this and simplify it. Same thing with the square root of 57. If it was like square root of 8, we'd expect you to do like 2 square root of 2 by simplifying the radicals. Now, make sure also that you're able to give the approximate values using your calculator. So if you were to put these in your graphing calculator and graph them, or excuse me, and approximate them, you'd end up with 3.14, or the other solution is -0.64. So exact solution, that's what these are. These are exact solutions right here, this one or the other one. This is exact. And then this, of course, the bottom ones are rounded. They're both the same solutions. There's just one's rounded and one's not. Okay. So again, number 1, factoring is a way to solve quadratics. 2, square root method. 3, the quadratic formula. And lastly, right here, this number 4, you can use, could we solve the same problem using a graphing calculator? Absolutely. So if you have it set equal to 0 in your y sub 1, you substitute that equation 2x squared minus 5x minus 4. So, and then in your y sub 2, what I do is I put 0 in there. The reason is because 1, I'm going to just kind of graph this kind of. Now, of course, my graph is going to be questionable at best. Let me do it in red. So let's see here. We have, if I put this in my graphing calculator, this is going to be a little over, well, 3.14. You see that as a solution. 1, 2, 3.14, about right there is my x-intercept. And my other x-intercept is going to be about right there, -0.64. And again, graph it, you know, with your graphing calculator, so don't just trust me. Graphing is a powerful, powerful tool. Now, here's the thing. In your graphing calculator, if we hadn't already solved it, you would have put this red equation in, which is, let me color code it, which is this one right here. And then let's put this one in purple, which is this one right here, the y sub 2 equals 0. And all you're doing is finding your intersections at those two spots. And again, you would find that this intersection is -0.64, and this one right here is 3.14. We use solving by graphing anytime that we have a nasty equation and we're allowed our graphing calculator. So as we move forward into Unit 2, you'll note that there's going to always be a calculator and a no calculator part of assessments. Okay, oops. Let me come on down here. It says 4 methods for solving equations. Well, we just kind of already reiterated, or we talked about them. Factoring. So factor, square root method, they all have their pros and cons. Root method, the quadratic formula, and then lastly graphing. Okay, factoring only works sometimes. It gives you nice solutions but doesn't always work. Square root method needs to be in the right form, which we talked about. It has to be in that vertex form. Quadratic formula is a pain. It takes a long time, but it will solve any quadratic formula, so it's huge, or quadratic equation, so it's hugely powerful. And then graphing, it's very, very visual, but it does not give you exact solutions. So yeah, so there's another method later, but we will stick with the ones I just showed you. So that was a very, very quick review of the solving quadratics. Now let's talk about absolute value. So if you were to graph these, they are V functions, but to solve it, you have 2 solutions, kind of like parabolas, where you're going to go 2x minus 5 equals 7, or the other equation is 2x minus 5 equals -7. and then you solve it from there. So you have 2x equals 12, and then x equals 6. 2x, oops, x equals negative 2, and then x equals negative 1. And I tend, when I'm kind of going fast, I tend to make this mistake, so I hope I'm doing okay here. I really, really suggest you check your solutions. So like for instance, I put 6 in, 6 times 2 is 12, minus 5, that gives me 7, and absolute value of 7 is 7. If I put negative 1 in, I end up with negative 2, negative 2 minus 5 is negative 7, absolute value that is 7. So I do know that it is correct. The reason I'm saying to check it is because this situation over here, there is not even a solution. Like you could force it, like you could come up with solutions, but they're not going to be solutions. The reason why is at no point can you do an absolute value and get a negative 9. So that's what this is saying right here. What value can you put in right here for x that would give you a number that when you find the absolute value of it, you'll get a negative number? That doesn't even make any sense because absolute value is all about positive values because we're talking about length, and length has to be positive. So there's no solution here, and that's what you would write for that one. Okay, now down here, down here we have a great big complex numbers talking about, you know, the different types of numbers, whether they're rational, irrational, imaginary, real, or complex. And really, let me just kind of keep going here, and I want to just focus right now on imaginary numbers. So imaginary numbers are the numbers that you know is going to be, let me just kind of, I can't do two things at once here. Here, I'll go right back to black. We know that I equals the square root of negative 1, where negative 1 is I. I squared is going to give you negative 1, because if you take negative 1, square root of negative 1 times square root of negative 1, that equals negative 1, because the square roots undo each other. So I'm going to have I squared equals negative 1. I cubed is going to be square root of negative 1 times the square root of negative 1. Now if I simplify that, I'll end up with negative I. So I'm going to give you a reason why we're kind of writing these patterns down here in a minute. You don't need to memorize them, but I do want to tell you that this is very powerful, I squared, obviously I itself. The other one that's super, super powerful is I to the fourth. Because if you think about multiplying really I squared times I squared, which is negative 1 times negative 1, you do end up with positive 1. So, or you can go negative 1 times square root of 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 negative 1 and simplify it, and I to the fourth gives you 1. It's lovely. So the reason I bring that up is because I to the fifth then, and there's not nearly enough room down there, but I'm going to do that down here. So I to the fifth, I could break down into I to the fourth times I to the first. So I can rewrite I to the fifth as I to the fourth times I to the first. Now I to the fourth equals 1, and I is just I. So I know I to the fifth is just I. Now if I keep going, and I can keep going here, but they don't get that interesting, but I'm going to say this ends up being negative 1 by doing the same thing I just said, negative I and 1. What I think is more interesting is this. If you have I to the 83rd, now you're not going to want to try to figure out a pattern on this. What you want to do is, if you can, write it in terms of I to the fourth, because we know I to the fourth is just 1. So I to the fourth raised to what power gets us close to 83? Now if you think about this, I to the fourth raised to the 20th power gets us to 80th power, and we still have I to the third left over. So all I'm doing is ripping apart I to the 83rd so that I have it in terms of the fourth power. Now, we know that this right here is the same thing as saying 1 to the 20th power. We know I cubed is negative I, and if you forget, you can just calculate it out. And so if you look at this, I to the 20th is 1, so this whole thing ends up giving me just negative I. Kind of cool. So you can do that with any of the I to whatever powers. Now I to the 0, is equal to 1, folks. Anything to the 0 is 1. Any complex number where you have a plus bi, any complex number to the 0 power is going to equal 1. Okay, so just kind of that's a little summary on imaginary numbers. And now, now I want to get down here to complex numbers. Complex numbers have both a real part, which is this right here, and then the imaginary part, this right here. So really, to add complex, subtract complex, and multiply complex is very much what you're used to, just combining what we would almost think about as like parts. So we have 9 plus a negative 5i, or you can write it, which is how I would write it, as 9 minus 5i. So subtracting, just be careful to distribute that negative. It's easy to forget. So you end up with 3 minus 2i minus 4 plus I. So this is going to end up giving you, oh, I can't even, my stylus is not working very well. 3 minus 4 is negative 1, and then negative 2i plus I is going to give me minus 1i. And you could say minus 1i, I just said minus I. This here you FOIL out, or extended distribution, however you're taught it. So again, this here, be careful to distribute that negative. Here, we're going to multiply out, FOIL out, so we have negative 6 plus 8i plus 3i minus 4i squared. So we end up with negative 6 plus 11i plus 4. And I know this isn't very interesting, but again, like I said, I would hope you're working these out and then just checking my answers to see that you're doing it right on your note guide. Okay, so just all those little things are super, super important for what we're going to be doing this next chapter. Evaluating, well, again, this is an Algebra 1 concept where I can break this up into negative 1 times 36. Negative 1 I know is I, square root of 36 is 6, so it would be 6i. This here, I like pulling out the I first myself, so I have I squared root of 8, but then I have to simplify square root of 8, so that I'm doing I, and then times the square root of 4, times the square root of 2, I'm breaking up that square root of 8, and then it's going to be 2i square root of 2. Complex conjugate, you're going to just multiply by the conjugate, which is 7 plus 3i here, and FOIL it out. Or actually, it's not even, it's just asking what the conjugate is. This gets rid of I, which is super, super cool. So conjugates are important to know. Like if I were to actually multiply by 4 minus I would get rid of my imaginary number. And this is kind of interesting. 2i is not like it is complex, 0 plus 2i. But if you think about that, the conjugate can be either negative 2i or just I. And this is what I use right here. And you'll see that in the practice. And again, just remember I is equal to square root of negative 1. And then I squared is equal to negative 1. Those are two important concepts. Down here, folks, right here, we're going to rationalize the denominator-ish, kind of, or put it in standard form. That's why we multiply by the conjugate. 2 plus 3i, what you do to the bottom, you do to the top. And when you multiply this out, you will simplify it, and you'll end up with 10 plus 15i on the top. And again, this is just putting it in standard form and getting rid of the I in the denominator, almost like getting rid of the square root in the denominator. And that's called rationalization. Minus 9i squared. Now this is the fun part because now you have 10 plus 15i up here. And down here, you end up with 4 plus, because these are gone, 4 plus 9. And that's going to give me 10 over 13 plus 15i over 13. Okay, rationalizing, but this is actually called putting it in standard form. This here, letter B, you want to get the I out of the denominator. If I multiply both sides by I by using the conjugate idea up above, that's going to give me 7i over 4i squared, which in turn is going to give me 7i over negative 4. And really, the better way to write this would be to say negative 7/4 I. Okay. Last but not least, just trying to keep the video so it's not so long, is solving using the quadratic formula again. I'm just going to let you know that when you do this, you should end up with the answer -2 plus or minus square root of -8 over 2. When you simplify this, you should pull the I out, simplify that radical, just like a but on the top, which would be 2I square root of 2 over 2. And then you can divide those out, and you end up with -1 plus or minus I square root of 2. Now, ladies and gents, I know this is a little longer video than I would have wanted, but I do want to say this PN5 right here is the page 50. PN6 is this right here, and it gives you the nice practice that you will need in order to make sure that you're ready for Unit 2. Thank you for tuning in.